All right, next thing, let's review how to solve exponential equations, okay? First of all, what is an exponential equation? An exponential equation is when the exponent has variables, okay? So when you're unknown, all right, usually it's like x or some other letter, in the exponent spot, whenever there are variables in the exponent spot, right, and there's an equal sign in the problem, that means you're dealing with some sort of exponential equation, okay? Now, the idea when it comes to exponential equations is you want to try and get the bases, all right, to be the same, right? So we should be able to get these bases to be the same, right? So you have to think 8 is the same thing as 2 to the third power, right? And then we have the 2x on the outside. 4 is the same thing as 2 to the second power. And then you have x plus 4 here. So now, if you follow exponent rules, we multiply these exponents. You get 2 to the 6x is equal to 2 to the, we distribute the 2. So remember, we're multiplying. You multiply the 2 here and here. So that will give us 2x plus 8. So remember to multiply the 2 to both of these values inside the parentheses. Okay? And then once you get the bases to be the same, so after we get the bases to be the same, then we can make the exponents equal. So now that the bases are the same, we can say, okay, so that means 6x can equal 2x plus 8, right? And then we just solve for x. So you minus 2x on both sides, we'll get 4x is equal to 8, divide by 4, so x will equal 2. Okay? So basically, that's the idea when you're solving exponential equations. All right, what you want to do is you want to get the same base, right? Because once you get the same base, you can make the exponents equal to each other and solve for the unknown variable. Okay, so that's the idea of how to solve exponential equations. All right. All right, so let's take a look at this example now. So we need to solve this exponential equation. So the first thing I would do is, well, I would look at these numbers right here. So if you see 32 and 16, you want to think, what number can I use to try and get the same base, right? So I know 32, that's 2 to the 5th power, right? And then I have this x minus 2 here. Now, this is 1 over 16. The first thing I would want to do is, I don't want this to be a fraction. So how do I make it not a fraction? I need to move the 16 to the top. Well, if you move the 16 to the top, that means it's going to become 16 to the negative 1 power, okay? So that's the first thing you want to do. You don't want this to be a fraction. Now this x minus 1 on the outside is still there. So now if we follow exponent rules, right, we're supposed to multiply these exponents. So this will give me 5x minus 10 when I distribute the 5 here and here, right? Same thing over here. Now this 16, right? Now you can distribute this negative 1 first. Let's just think of this as 16. I distribute this negative 1 here and here. That will give me negative x plus 1, right? And then, well, 16, we want to think of this as, well, what's this going to be? This is the same thing as 2 to the 4th power. And then we have this negative x plus 1 outside here, right? This is 2 to the 5x minus 10. So we follow exponent rules. We distribute the 4 now. So this will give me 2 to the negative 4x plus 4 is equal to 2 to the 5x minus 10. So now that we've gotten the same base, right? So once we get the same base, right, we can say these exponents have to be equal to each other, right? So then now we know that 5x minus 10 has to equal negative 4x plus 4. So if you add 4x here, that'll give you 9x. Add 10 over here, that'll give you 14. Divide by 9, so we know x is going to be 14 over 9. Okay? All right, let's take a look at this example right here. All right, so the first thing, we want to take a look at all these values right here, right? If you're solving an exponential equation, you want to first think, what number am I going to try to use to try and get the same base? So I see this right here. Well, this is 2 squared. And then I have the x plus 4 on the outside. On the bottom here, Now, same thing. I don't want this to be on the bottom, right? So I want to move this up. So first of all, I'll move this up. So this would become 8 to the negative 1 power, right? And then I still have this x minus 3 on the outside, okay? And then I have times, we have this 2, right, to the x plus 1. Now, I'll distribute this 2 here and here. So this will give me 2 to the 2x plus 8 is equal to, now over here, you could distribute this exponent first and worry about changing the 8 later. That's fine. So this will give me negative 1 times x. So that's negative x plus 3 times 2 to the x plus 1. Now, we need to get the same base. So over here, this 8, let's change that to 2 to the third power. So this is 2 to the third power. And then I have this negative x plus 3. So if we follow the exponent rules, we're going to multiply these exponents. Let's distribute the 3. So we get 2 to the negative 3x plus 9 times 2 to the x plus 1. All right, on the left side, we still have 2 to the 2x plus 8. Okay, so now on the right side, right, we have to recognize that, well, on the right side here, if we're multiplying and we have the same base here, this 2 and this 2, all right, we're supposed to add these exponents right here. So that's what I'm going to do. So I'm going to add these exponents. So that'll give me negative 3x plus 9 plus x plus 1. So I'm going to simplify this right here. So that's going to give me right here 2 to the negative 2x plus 10, right? So the right side, when it's fully simplified, right, we're going to end up with 2 to the negative 2x plus 10 is equal to, on the left side, we have 2 to the 2x plus 8. Now that we've got the same base here, right, we can say the exponents have to be equal. So we can set the exponents equal now. So if we set the exponents equal, we're going to end up with 2x plus 8 is equal to negative 2x plus 10. So add 2x to this side, we're going to end up with 4x, right? So this is going to be 4x is equal to minus 8 on both sides. This is going to be 2. Divide by 4, so x is equal to 2 over 4, which reduces to 1 over 2. Okay? All right, so let's take a look at this last example here. So if we need to solve this exponential equation, right? So if you have a fraction equal to another fraction, so you guys remember that you can always cross multiply here, right? So that'll give us 6 to the x power times 6 to the 2x is equal to, then we're going to cross multiply this way. So that'll give us 36 times 36 square root 6. Okay? So now that we have the same base on the left side here, so we've got the same base, I can add the exponents on the left side. So I get 6 to the 3x power. On the right side here, so I think it's obvious that we're going to use 6 as the same base, so I'm going to change this 36 to 6 to the second power times this 36 is also going to become 6 to the second power. Now 6 square root of 6 is going to become 6 times 6 to the 1/2, right? So now if we're simplifying on the right side here, so we have the same base, all of these are 6, right? So I can add the exponents if I'm following exponent rules. So I have 6 to the 2 plus 2 plus 1/2. So that's going to give me 6 to the 4.5. So 6 to the 4.5 power is the same thing as 6 to the 9 over 2 if we change this into improper fraction, right? So now the problem becomes, on the left side here, I have 6 to the 3x power is equal to 6 to the 9 over 2. So now that we have the same base, 6, right, we are allowed to say the exponents need to be equal, right? So that means that 3x is equal to 9 over 2, all right? So when you divide by 3 on both sides, right? So we divide by 3 on both sides. So we're going to end up with x is equal to, we get 9 over 2 times, so dividing by 3 is the same thing as multiplying by 1 over 3, right? So 9 over 2 times 1 over 3, that's going to give us, I believe, so the 3's divide out here, and then that'll give me 3, so we get 3 over 2, right? So our final answer is going to be x is equal to 3 over 2, okay?